Okay, so the first thing we should normally do when we look at a circuit like this is to try to simplify it as best we can. And so how I'm going to do that is I got this point A here and point B, and I'm looking for the resistance across that. So I'm going to look at these resistors here and these resistors here and sort of stretch this circuit out to see what it's going to look like. Now these two resistors are in series with each other. So I can draw them like so. Where we have points B and A. These two resistors are also in series with each other. So I can draw them like this. Now each of these has a resistance R. So what you'll notice is we have two resistors in series in parallel with two resistors in series. So I can reduce this more by finding the equivalent resistance of these two and then the equivalent resistance of these two. And since they're in series, this becomes very simple. The equivalent resistor here are points A and B. And then this side reduces to an equivalent resistance. And since these are both in series, then we just add them. R plus R gives me 2R on this side. R plus R gives me 2R on this side. So what I have now is two resistors with a resistance of 2R and parallel with each other. So I can figure out the equivalent resistance using the equation for parallel resistances. And this becomes 2 over 2R. So the equivalent resistance for this entire circuit between A and B is equal to the resistance of any one of these resistors.